Welcome to Algebra 2. Our first unit is actually just going to be a quick checkup to make sure that you remember a lot of your Algebra 1 skills, and then we'll have a little assessment at the end and then start with our new material. So first, let's just make sure you can solve equations. This one has multiple steps. First step obviously is to distribute. Negative 6 times 7 is negative 42. Negative 6 times negative 4m is positive 24m plus 5m. Just bringing the rest of this down in your 3m plus 36. Then you combine like terms on each side of the equal sign. On the left, I can put these m's together. So then I'd have negative 42 plus 29m equals 3m plus 36. Then I want to take all my m's to one side. So if I want to bring these m's to the left, I would subtract them since they are positive. After I do that, I'm actually going to write what I get over here for more room. So I'll have a negative 42 plus 26m equals 36. Then I will add 42 to both sides. Hopefully this looks familiar to you. And we have 26m equals 78. Then I will divide by 26 on both sides, and I will get m equals 3. And that's my answer number 1. Number 2, solving an inequality. And I'll be quite honest with you, solving an inequality is very similar to solving an equation. You just have to be careful if you divide by a negative or multiply by a negative. In this one, I'm going to distribute first. Negative 2 times p, negative 2p, negative 2 times 1, you're negative 2. Then I'm going to take all my p's to one side. In this problem, I'm definitely going to bring my p's to the left, because if I add 2p to both sides, then I'll have positive. And I'll be honest with you, I'd much rather work with positive numbers. So this is 1p and 2p gives you 3p's. And then I'm going to add 23 to both sides. And I'll have 3p is greater than or equal to 21. Divide by 3. P is greater than or equal to 7. But don't forget, any number greater than or equal to 7 is an answer. And many times when there's more than one answer or infinite solutions here, we're going to go mark that on a number line. We'll use a solid dotted 7 because it's allowed to be 7. And it can be anything bigger or greater than that, and that would be any number to the right. So I like you to get this solution and then also graph it. If you go to number 3 and 4, these are both compound inequalities. This first one is what they call an and, because this expression must be less than 109 and this expression must be greater than the negative 61. I also like to say it needs to be between those two numbers. So I moved it down here so I would have more room. And I'm going to solve for the p, so I want to get the p by itself, so I'm going to subtract 9. Now this one's a little unusual because you don't do it to both sides, you do it to all 3 sides. There's a left where you're going to subtract 9, a middle, and a right. When you do that, you get negative 70 is less than negative 10p is less than 100. Then I'm solving for p, so I'm going to divide by negative 10. And this is the worry when you're solving inequalities. If you divide by a negative, you must flip the symbols. So we would get 7 is greater than p, which is greater than negative 10. Now, I'm going to be honest, that is completely correct. However, most of the time when they write things in this compact form, they use less than symbols, where the smaller number is on the left. So I can take this and rewrite it and have it be negative 10 is less than p is less than 7, means the same thing. Smallest number it can almost be is negative 10. Biggest number it can almost be is 7. And it can be anything in between because it must be less than this one and greater than the other one, and that's where that would overlap. Next is number 4. This one is an OR. Just solve each of them individually and graph them. So here is your first one. We'd subtract 5. 8n is greater than negative 16. Divide by 8. N is greater than negative 2. So that would be an open dot at negative 2, arrow to the right. And again, I don't care if these overlap at all. It's an OR problem, which means it can be anything here or anything I get with this answer when I'm solving this one. So I'm going to subtract 6. 9m is less than or equal to negative 63. Divide by 9. M must be less than or equal to negative 7. So solid dot at negative 7. Oops, right here's negative 7 and anything to the left. This is your typical picture for an OR. They don't always have to look like this, but it doesn't matter if they overlap or not. Anything over here is an answer. Anything over here would also be an answer. So let's look at 5. Now we're solving an equation with an absolute value. And what you want to do anytime you have one of these is make sure you get that by itself. So the first thing I'm going to do is subtract 9. When I do that, I get negative 4 times the absolute value of a plus 8 equals negative 44. I'm still not ready to solve the absolute value part. I must get the absolute value expression by itself. So I'm going to divide both sides by negative 4. So the absolute value of a plus 8 has to equal positive 11. Well, hopefully you remember that absolute value is distance from 0. There are actually 2 numbers on the number line that are 11 away from 0. Those 2 numbers are 11 and negative 11. So this stuff inside could equal 11, or stuff inside could equal negative 11. If I solve those, a could equal 3, or a could equal negative 19. There are 2 answers many times when it is an absolute value equation. Now I'm going to do one more on this page. It's an absolute value inequality. Same thing, get the absolute value by itself. So you would add 8 to both sides. Then I'm going to write it down here. I'll have 10 times the absolute value of 7 minus 9p is greater than 70. Again, I have to get this guy by itself. So I'm going to divide by the 10. Absolute value of 7 minus 9p is greater than 7. Well, this stuff must be more than 7 away from 0. So that stuff needs to be greater than the number 7, or that stuff would have to be less than the number negative 7. And I always said when I taught Algebra 1 that I think of this as greater, so I don't forget to write the or between them. And then I solve them. Now before I solve them, I want to let you know, I know many teachers say, write it without the bars, and then write it where you change the last 2. That's also a way of saying it. I just like to think in my head what numbers are more than 7 away when I write it. I'm going to subtract 7. Negative 9p is greater than 0. Uh-oh, don't forget, you're dividing by a negative. So I need to flip that. So p is less than 0. We'll do the other one, subtract 7. Negative 9p is less than negative 14. Divide by negative 9. And I'm dividing by a negative, so I'm flipping it. Now, technically, feel free, please, to leave it as 14/9. That's like an exact answer, no rounding. But I'll be honest with you, I need to sometimes think about what that is as a decimal. You'll see on my calculator I typed in 14 divided by 9 to let me know that it's about a little more than 1.5. So I'm going to write myself a little note. That's about 1.56. So when I go to graph it, I'll do this part. Open dotted 0, arrow to the left, and open dot between 1 and 2, a little more than half, and arrow to the right. And that is page 1.